So for the next thing we're talking about, it is applied learning. And students are not only doing the math and the physics, but they're also learning how to engineer. They're learning how to build. They're learning how to put things together in a different way. They actually have to use a power saw. We teach them how to use it. We do safety, with them and all that kind of stuff. But they actually use a power saw. They use a hammer for the first time, most of them. And they learn how to build something. They also learn the engineering process of, okay, it doesn't work. Let's take it down, fix it, and make it better. Or it is working. Let's improve it. How do we do that? So students actually learn so many different skills in this project beyond just the math and physics.
And with that, there's a lot of group collaboration that goes into it as well. So we set up our groups in a very specific way. So we had a couple of strong students in the group and a couple of students who weren't necessarily the strongest, so they could help each other out, which is just common practice and best practice with group collaboration. But in addition, with respect to each of the benchmarks for the project, every group member had to meet that benchmark before the group itself could move on. So for instance, we had our first set of benchmarks that really aligned to all the content behind the projectile motion, so they could actually model the pathway of their projectile. They had to complete all those assignments, and then after that, they got all their design materials so they could actually physically build their catapults. They were then given some class time to be able to build those catapults, but again, with group collaboration, there's a lot of ideas that each student had, so they had to be able to find a way, a facilitator did, to be able to get each of the ideas on the table, to be able to speak about which type of catapult they wanted to build. Was it an onager? Was it a catapult? Was it a ballista? Was it a trebuchet? They then had to work together to be able to use their minimalist materials to be able to create this type of ballistic machine, which required a lot of different group collaboration. In addition, at the end of the project, they had to fill out a peer evaluation rubric where they said what they liked about how they worked well with other group members and what each group member did, as well as the wonders and how each group member could improve on collaboration with respect to communication.
And so what we do is, with all of our projects, we actually, in our agendas, put more time at the beginning for the first benchmark, and then we give them less and less time to complete the project as it goes on, so that they learn that if they work really hard at the beginning, they actually have more time on their other benchmarks that may be a little bit harder. So a lot of groups actually learn different time management skills through that, and they make sure that they are on top of the project and really being good in agency and that kind of stuff.
And in addition, the students also know there's a lot of resources that they have to take the initiative to use. So for instance, all the worksheets and all the activities that align to the content, we have answer keys for on Echo for them, so they could go over the answers, make sure they understand them before they move on. Because of course, they don't understand the answers on that worksheet, that activity sheet, they're not going to be able to do the real-life calculations with their physical catapult. In addition, they also had video lessons that were accessible to them with respect to each workshop we did in class. We posted a video of that lesson on Echo, so they could refer to it, they could review it, they could figure out what parts they knew and what parts they still had questions about for the next benchmark or the next activity.
And the ultimate reason that this is really applied learning is because they apply it to their catapult they build, and they shoot it off. And if they don't hit the target, they know right away if they did it right or not. So it's significant in the applied category for this project.
And of course, there's a little bit of competitive edge because the team with the most number of points based upon what things they hit on the castle do get to raise their little flag in the middle of the castle saying that they had a victory in the Bomberg Castle Siege.